Okay, so we have, it's a pretty standard problem. You got a boat that goes upstream, comes back downstream. There's a current, in this case, a 3 mile an hour current. And you're given that it takes 12 hours longer to go upstream than it does downstream. Okay, so, and you're also given the distance. Now, in this case, we're going to use the fact that distance over rate equals time, or distance over speed equals time, speed being the rate in this case. And sometimes the rate might be the rate at which you get a job done. And or it might be rate of return on investment or whatever. In this case, rate is a speed, so I'm going to replace the word rate with speed. Now, what you're asked for is how fast will the boat be traveling in still water. So we let X equal speed in still water, and then we try to assemble our information. So what we have, what everybody got to is you have get 110 miles. Time upstream, 110 miles over X minus 3 miles an hour. Because of course, if X is your speed in still water, and you're traveling upstream against a 3 mile an hour current, your speed upstream is going to be X minus 3 miles an hour, 3 miles an hour less. And then downstream, is 110 miles an hour over X plus 3 miles an hour, just coming downstream. Current's helping you, you're going 3 miles an hour faster than you would in still water. Remember, X is your speed in still water. Now, this is pretty much the way everybody's got the problem set up, except we're not real consistent about how we label what this means. This is a time upstream, this is a time downstream. We got time, but we don't have a specific time upstream and time downstream. And that's important because we've got a relationship between the time upstream and the time downstream. Okay. And that relationship is the time up. It's 12 hours more than the time down. So if you write the time up and then the time down plus 12 hours in terms of expressions we already have, you're going to get an equation you can solve for X. Okay, just take a look at the long division problem. The way we do this is we want to have something up here, which when it's multiplied by this, gives us as much of this as possible. It's like if we divide 5 into 41, we get 8. 8 times 5 is 40. So they just want, right? So first of all, really ought to do a few division problems with numbers. Kind of prime yourself, because you probably haven't done a lot of long division since you're in 5th grade. Okay. But we really have to understand this process in order to get an idea what's going on here. And again, the idea is that 8 times 5 gives you 40 out of the 41 that you need. If there's one more left over. So this would be 8 with the remainder of 1. Or 8 and 1/5. Okay, over here. Divide x plus 3 into this. We want something here that multiplies x. Gets rid of that x squared. And that would be x. And multiply x by x, I get x squared. And multiply x by 3, I get 3x. Then take put a little tiny minus sign here, a little tiny minus sign here, because just as we subtract over here, we got to subtract this from this over here. So well, we subtract x from x squared, we get 0. We subtract 3x from 4x, we get x. Now we have x plus 11. Then, what do we need up here in order to get rid of this x? Well, we need a 1. And 1 times x plus 3 gives us x plus 3. So when we subtract the x and the 3, we end up with 8. So we get x plus 1 with the remainder of 8. So let me give you another one just to work on, see if you can imitate this. It'll be very simple. I'll throw a little bit of a curve in. Try that one. Okay. Got this. In order to get an x squared, we have to have an x. And x times x is x squared. Of course, since whatever we have here, we're going to multiply by this whole thing. X is also multiplied by the -2. Well, don't give let you do that. Then we write little tiny signs here, minus sign here, because we got to subtract whatever we got. And we've already got x squared minus 2x. What more are we going to need to get all this? Put a little plus sign here. Okay, I don't change the sign of x squared. I don't change the sign of 2x. I keep those signs exactly as they are. They're right little reminders by myself that I'm subtracting. And so we subtract from -2x and 4x. We're going to get -2x. Of course, we're going to have a 7 there. Then what do we have to do? Well, what do we have to multiply x by to get the -2x that we still need? Okay. That was just making sense of it a little bit. We need a -4x. Multiply whatever we have here by this. Okay. And starting by multiplying by x, we've already got a -2x. Now we need another -2x. Get that -4x. So what we have to do now is we do a -2. So we have a -2, then we're going to get the -2x that we need. But we're also going to get a plus 4. It's -2 times -2 plus 4. Okay, well, write down a little plus sign here and a minus sign here. Now we've got 3 and no way to get that 3. Nothing up here we can multiply by x minus 2. Then give us a discretion, that's what's left over. But we have a remainder of 3. Let's try that. Try to imitate every step. Okay. Here, we're gonna get an x there. It's gonna give us an x squared. And then x times 4 is 4x. Well, let's get this, because this is where most of the mistakes occur. People do the thing, it's confusing, contracting, negatives, positives, it looks like he's subtracting instead of adding, and really deconfusing. Follow this algorithm, make sure you write those little negative signs here. Comes out. That's one of us. Then get a 2x down here, we're gonna get that plus 2. We get 2x. Uh-oh. We get 2x plus 8. Okay, now, I think maybe I caught an error, because it should be 2x plus 8. I think maybe somebody had a minus here. Because the 2x plus 8, then we subtract, we write the negative sign, we're doing minus 9 minus 8, which is the same as doing minus 9 minus plus 8. That's going to give us negative 7. Okay. Now let's get the process now. Let's try this. That's plus 2 into 4x squared plus 9x minus 5. This is a whole new problem. Clear out some more space. You'll probably work it over. Okay, so see what we do with that.